How typical CNC lathes move. In this video, we'll discover the work coordinate system of a lathe, identify the differences between a lathe and mill, and explain tool direction.
So now we're standing in front of our Haas ST10Y. This is a turning center or a lathe. The main difference between a lathe and a mill is that in the mill, the tool is spinning, and in a lathe, the material is spinning. As such, the layout of the axes in the lathe is a little bit different than what we talked about in the mill. So, what you'll see here is the lathe spindle. That's where we're going to put the material in, and the material will be spun around. That material is spinning around the C-axis. So if we remember from before, we talked about XYZ equals RGB in terms of axis colors. When we talk about rotational axes, we can remember XYZ equals ABC. So when we talk about the C-axis rotating, that C-axis will be rotating about the Z-axis. So in this machine, the Z-axis is the direction axially along the spindle. Now in your typical lathe, you're going to have the Z-axis and the X-axis. The X-axis is going to be the tools coming in towards the material. We can see here we've got a tool holder. In the case of this lathe, it's a turret with multiple tools loaded. And those tools will come down and they will approach the material from the top side. That is our X-axis. Now, this lathe being an ST10Y also means that it has a live Y-axis, which is not common on all lathes. What that allows us to do instead of just basic turning operations is to also use this lathe for milling operations, often referred to as a mill turn machine. Now the Y-axis in this case will be at 90 degrees to the X-axis. So if our X-axis is coming in towards the material this way, the Y-axis will move the tools in and out that way. You can see from a tool perspective that I have tools that are along the X-axis pointing at the material, and I have tools that are along the Z-axis pointing along the center line of the material. Those are traditionally the two types of tool orientations that you will see in a lathe. Now this machine having a live Y-axis means that some of these tools can actually spin. So if we were doing milling operations, the lathe would stop the material from spinning, it would then spin the tool, and it would move it in X, Y, and Z as you would expect on a standard mill. That way I can get axially symmetric round parts, but I could mill flats or grooves or other things into them that are not axially symmetric. So much like we talked about on our milling machine, the machine itself has a home position, and then there's a zero position for the stock material that we often refer to as the work offset, or sometimes you'll hear that as G54. On a lathe, it's a little bit different than it is on the mill. So if you remember on the mill, we changed position in both X, Y, and Z to set our G54 on the stock. On a lathe, the only thing we need to change is our Z position. When you program a part for a lathe, you're going to set your part 0 to the center line of the material or the center line of the spindle. That will be X0, Y0. That doesn't need to change between the machine coordinate system and your part coordinate system. So all we have to do is move the machine in the Z direction to the face of our part, and we can set that as our Z0, and that will give us our G54.